have a 3 kilogram Pulley engine. That's going to pull a 5 kilogram cart. So they're attached by a string. The force being exerted by the 3 kilogram is 29.4 newtons. I want you to find me the acceleration of the two objects. Go. It's not on the page. Find me the acceleration of the two objects. The force pulled is the 3 kilogram object. So force on the first car, it's pulling is 29.4 newtons. What is the acceleration of the two objects? Okay.
Is it 3.675?
And how did you get that?
The total mass, or the newtons divided by the total mass.
Okay. 29.4 divided by 8. Okay, great work. Okay. Now what I want to do is I want to find the net forces on the 5 kilogram. So tell me all of the forces that are working on the 5 kg right now. No, not force applied, no. Tension. So which way is the tension working? Towards the 3. Good. So I have tension. Go ahead.
Gravity.
Force of gravity. And normal force. Okay. So is there any vertical net?
No.
No, they cancel out because it's on a flat surface, right? So the only force that's working on it then is the tension. Would you agree with me? Yeah? Okay, so then how do I calculate what the tension force is then?
9.8 times 5.
How come 9.8?
That's force of gravity. Yeah. It's
No, no,
the
I
same.
want to
Oh,
find the
okay.
tension force.
Oh, never mind.
Not the normal force, the tension force.
Okay.
Okay? So how do I find the tension? I don't have force of friction. I only have one force acting on its tension.
Could you connect?
Okay, so take my mass. Okay, how come? What is my net force equal to? On that 5 kilogram? What's moving it? Tension. Subtract my friction, which isn't there, right? So the only force acting on it is tension. Therefore, the net force on it is just tension. Do you agree?
Yeah.
Yeah? Okay, so then what's the mass of that object? 5. And what's the acceleration of it? 3.675. So what do I get my tension as?
18.375.
Okay. Does everybody agree with what we've done here so far? Is there anybody that has an issue with that? Anybody have a problem with it? How many of us could do that question? Who can't do that question? Be honest. Who cannot do that question? Anybody? Watch. Y'all did that question just now. What's the force of gravity on the 3? 4 newtons. What you just did, right there, is what you need to do here. All the same steps. It's the exact same question. The only difference is, I gave you this, and you needed to solve it here. So when you're doing these Pulley questions, you've already done all these questions. You're overthinking what's happening here. By me just putting these beside each other and telling you what the force is here, okay, I could have just hung the 3 kilogram over a pulley and you would have done the exact same thing. You find the force of gravity that's moving them. Then you divide by your total mass, which is 8 kg, right? You got your acceleration 3.675 meters per second squared. Once I have that, I then find all my forces on my 5 kg. And what's the only one that affects it? The tension force. So then how does this question change? So now, what if I wanted to find the forces on the 3 kg? So look at the 3 kg now. What are the forces? Oh, I don't want to do that here, sorry. Just a second. Over here. What are the forces affecting the 3 kg?
Force of gravity.
Force of gravity.
Tension.
What's holding it back?
Tension.
Tension. So to then get my net force on the 3 kg, what's moving the 3 kg? Gravity. What's holding it back? Tension. So now I can find out what the tension is using the 3 kg. Mass 3 times 3.675 equals 3 times 9.8 minus the tension. Alright? Subtract that to that side. Times by -1, we would get the same thing, which was, what was it, 19.375. Same thing. Okay, so what I've just done is the first question on the pulleys. Now, I did that right here. Okay, so when you're doing these questions, you're not doing anything that you haven't already done. Okay, you have to simply find out what the hanging force is that's moving them. Okay? I had a lot of questions about that yesterday.
I have a question. When we're always writing out the force net equals something with force, gravity, and tension, we usually put the one that had a greater force first. So then, wouldn't the tension be greater than the gravity since the 5 kilograms is greater than nothing? So the force net is force
Which way are they moving, Lexi?
that way, down, so I guess, but the,
So then what's moving it?
okay.
But this one won't be moving down because the 5 is holding it
It's
up.
moving to the right though.
Yeah,
So what?
your tension would be first if you're looking at the 3. Oh no, 3 is in the 5. Okay.
The two of you answer your own questions.
Yeah, I got it. Okay.
The only way that question changes for you guys is if they added friction into it. But for question 1 and question 2, they don't add friction. So they're done the exact same way. And the only thing that changes if they add friction, the only thing that would change if they added friction is your net force on this guy. Sorry, I left mixed up. The net force here would be the force of gravity of the 3 minus the force of friction on the 5. That's the only thing that changes if they add friction in there, because that's what's holding the 2 of them back. Okay? The first 3 questions do not deal with friction on that page. Are there any other questions from yesterday that people want to look at other than the 3 pulley questions? Yeah.
Number 5 on 166. The answer's 7.6 seconds and I got 7.4.
Okay,
Okay, you know what? I'm gonna let everybody go through it so I don't do it. I'll come look at yours and see. That's for B with the coefficient of friction being 0.1?
Yeah.
Okay. I'll do it with you and we'll check that out. Are there any other questions?
Number 2 on page 158. All I have is a mass. I don't have any other torque.
Yes, you do. You have the acceleration of gravity. It's hanging. Correct?
Mm-hmm.
So you have you do the question now?
Yep.
Any other issues?
Elevator, would you use the force of gravity as well for acceleration if there's no acceleration?
If there's no acceleration, then the net force is 0.
Oh,
And that means that your force of gravity and your tension is the same.
okay.
Okay, so if it's moving at a constant velocity, your net force is 0. Okay? If it's at rest, your net force is 0. Then these two equal each other. If it's moving down, then this is greater than this. If it's moving up, the tension is greater than the force of gravity.
Oh.
Okay? Does that answer your question?
so if we have friction acting on that number, friction did on the 5 kilogram, then it just wouldn't have moved it all.
No, it doesn't. You don't know that, Lexi. You don't know which one is greater. The force of gravity on a 3 kilogram hanging could still be greater than the force of friction on a 5 kilogram sitting on the surface.
Oh, okay.
Right? Like your coefficients of friction, like let's say your coefficient of friction was 0.1. So you've got your net force is equal to the force of gravity, which was 29.4 newtons hanging, minus 5 times 9.8 times 0.1. Let's say that was the coefficient of friction. It's a hypothetical question now. That's 49, okay? Times 0.1 is 4.9. So if I have a coefficient of friction, it would have to be quite large in order for that not to move. It has to be greater than the force of gravity for it not to move, or equal to it. You follow what I'm saying?
Yeah.
You think so? You sure? So, as long as this times whatever the coefficient of friction is stays below that, it's going to move. It would have to be greater than 29.4 in order for that not to move. Okay. You should be to the end of question 7 today. If you're not, you should get there. As well, there's 7 more questions on 174, 175. You will need to do those tomorrow.
Did you say you're gonna wait till?
I won't wait tomorrow. And then there's 4 questions on 183, but I don't think you'll get there. Although I do want to look at, no, I'll leave it for now. Okay, those 14 questions need to be done for Monday. Okay, let's have a look at that.